Hello and good evening. Welcome to Lab Activity 2 and a return to our regularly scheduled programming. Hope you all are doing well. I'm here. Hit me up with questions. I'm up in Discord on our Lab Activity 2 voice channel. If you want to get at me there, I'm also here on YouTube. You can hit me with questions in the comments. But let's rock and roll. All right, Samantha, let me pull up the lab activity out of Canvas, and we'll take a crack on question 2. Samantha, quick question. Are you asking about the question 2 on the in-lab assignment is what I'm wondering. All right. Okay. Awesome, Samantha. Thanks for that clarification. Okay. So let's kick things off with in lab 2, question 2. All right. So here's the question. When weighing solid objects, such as samples of metal, what equipment is best suited to contain the sample? All right, and the options are graduated cylinder, this one I'm just gonna give the answer because I can't change the numbers on this guy. A beaker, a weigh boat, an Erlenmeyer flask, oops, misspelled Erlenmeyer, and a burette. All right, so each of these fulfills a very specific function. Actually, all right, so something to be aware of is both beakers and Erlenmeyers are used for more or less the same purpose. These are used for storing solutions during an experiment. All right, so those aren't what's good for weighing out a mass. And actually, funny story, there's another two that serve the exact same, or not the exact same, but similar roles. Both a burette, oops. There we go. Both the burette and the graduated cylinder are used for dispensing exact volumes. And which leaves us with one last contender, and that is the weigh boat. This is what you use for recording masses. And the simple idea behind a weigh boat is, we weigh all sorts of things in lab, all sorts of solids we deal with. And you don't want to put the solids directly on the scale because then that surface can become contaminated with the chemicals that you use. And if you use two chemicals, put them directly on the same surface, there may be a little bit left over. And what if they're incompatible? They react. Bad things can happen. So you put a little weigh boat, which sometimes it's usually like plastic. You put it on the scale, and then you put your solid into the weigh boat, which is on the scale, and that allows you to keep the surface of the scale clean. So Samantha, that is in lab 2. And the thing is, this is a question where they're trying to teach you what these words mean. This is the type of stuff that you just pick up naturally in lab, because it says get a wayboat, and then you have to go to the wayboat station, grab one, right? Or get a beaker and fill it with this, and you know the difference because you've handled all of these. So this is one of the deficiencies of the kind of online learning, online teaching situation. But online lab simulation. I'm doing the online teaching by explaining these things to you. Okay, let's see. We've got more questions up in the chat. Let me just pop over to Discord to make sure I haven't missed. Nope. Nothing yet. Okay. Let's take a look. Okay, next in the chat. Lizette, you have a question. Okay, numbers 9 and 11. Lizette, let me pop down to those. All right, yeah, these are the ones with the simulators. These ones can be a little finicky. Okay, Lizette, I am looking um, at number 9 right now. Okay, and so you're saying you keep getting a thing that says source vessel does not have enough volume. So, or actually, I should just do 9 right now. All right, so, excuse me. So here's how I would attack this situation. So what you're doing in this portion, in this step, is you are calculating the density of an unknown metal. And as we know, density is equal to mass over volume. Now, the mass you record using a scale, right? Which is pretty straightforward. You place the metal on the scale, see what it reads, record the mass. To measure the volume of a solid object takes a little more technique. This you're going to measure by displacement. All right, so the deal is here, when it comes to measuring volume by displacement, what you're doing is you have you should do this with a graduated cylinder. All right, and the idea here is you are going to add water to it, and it's super important not to add, well, so I'll talk about what's important to do in just a minute, but you add some amount of liquid, record the first volume, then you add your metal, you drop your metal into the Erlenmeyer flask, and what that's going to do is it's going to cause the water level to rise. And then you get your second volume. And the reason why the water level rises is because the metal is now taking up space, so it is displacing the water. It's pushing it up further into the graduated cylinder. And if you take the difference in volume, this triangle is the capital Greek letter delta. It means change in. Change in volume is equal to your final volume minus the initial volume, and this is the metal's volume. All right, this is the volume of the metal. So that is how you determine the denominator, and then you can determine the density. Now, there's a couple things you should be aware of. First, you need to make sure that you so do not overfill the cylinder. I would recommend filling it halfway. The second thing you want to do is select the largest graduated cylinder you have available. They give you several choices. Pick the biggest one, because that will give you the best chance at actually holding the water and your chunk of metal without overflowing. I think it's like a 50 milliliter one. I think that's the biggest one. That's the biggest one I can see over here. So yeah, so I would grab that one. So Lizette, I'd say give those, give that a try and see if it works out for you. And let me know if that helps. So it shouldn't really matter. So it shouldn't matter as long as, one, your cylinder doesn't overflow, and two, use the same amount of metal that you weighed. That's critical. You want to make sure that the volume is of the mass that you weighed. You don't want them to be different. Okay, let's see. I'm working my way through the comments. Let me know if V1 and V2 make better sense now. All right, Kaylee. Table 1 of the lab. Okay, Kaylee. Thank you for being patient. So Kaylee, it actually doesn't matter how much you use because we're measuring density, which is a ratio between mass and volume. So, and they scale together. So you can do a little bit and get an accurate density. You can do a lot and get an accurate density. The one thing to watch out for is you don't want to use so much mass that your cylinder can't hold the water plus the metal. If that is the case, then you'll have to start over. But you can just use a little bit, fill the cylinder about halfway with water, and you're good. All right, let's see. Abigail, I can totally help with question number 5. All right, let's see. First, I gotta find question number 5. Okay, let's see here. So a student weighs an unknown metal. It is found to have some given mass. A sample is inserted into a graduated cylinder partially filled with water. The water in the cylinder is initially recorded. Okay, Abigail, this is a great question. And this is actually essentially walking us through what you're going to be doing in this lab. So this is question number 5. So I'm gonna, change the numbers. So it says a student weighs an unknown metal. It's found to have a mass of 48.813 grams. Then it says the sample is inserted into a graduated cylinder partially filled with water. The water in the cylinder is initially, so this is our V1, is initially 21.8 milliliters. After the metal is added, the liquid's level rises to 29.4 milliliters. And we're asked to find the density. Well, we're asked to find the density, but we know that density is equal to mass over volume. We've got the mass, right? It's right here. So we got our numerator. Initially, what might be confusing about this problem is you might be going, well, we need to find volume, but what volume do we use? We've been given 2 volumes. And the answer is both. Because the deal is, the reason why you have 2 volumes is you're given a graduated cylinder with some water in it. This is volume 1. The metal is added to the graduated cylinder, which causes the water level to rise. And now we have our second volume, and the thing is, the amount by which the water has risen is the volume of the metal. So our volume here is actually equal to the final volume minus the initial volume. We're finding this by difference. So it's equal to final 29.4 mils minus 21.8. And I'm not going to do this in my head because my brain has atrophied. Maybe when I was younger. 29.4 minus 21.8 comes out to be 7.6 milliliters. Sig figs wise, things are fine right where they stand because both of these numbers are precise to the first decimal place. My answer is precise to the first decimal place, so I can leave that there. Now that we know our denominator, we can calculate the density by taking 48.813 grams divided by 7.6 milliliters. And no matter how sharp my mind was at one moment in time, there's no time in which I could do this math in my head. Whoops. 48.813 divided by 7.6. So density is equal to 6.4227631,579. We're limited to 2 sig figs because of the denominator. Our numerator has a lot more. It has 5. So you count off your, your first 2. This 2 is going to round down. So our density is 6.4 grams per milliliter. All right, so let me check on problems 3 and 4. Let's see. Let's see, problem 3. Use the displacement to determine the volume. Yes, okay, so Lorena, question 3 is they're asking you to find the volume by displacement. Which is literally just the volume part of the previous problem. It's you're taking your final volume, subtracting your initial volume from it. And then question 4, here, hang on one sec. Yo, dude, but you gotta go. I'm like teaching and stuff. All right. Sorry about that. I had one of my kids was coming in. Okay, so that's question 3. Let me see question 4. Use the displacement to measure the volume. Yeah, totally. Actually, question 4 is the exact same deal as question 3. You're just doing it. You're measuring the volume of ice instead of what lead was in question 3. Yeah. Here, let me pull it up. So for example, if we're measuring the volume of lead, so one thing you have to do is you have to set the fluid density to around 1 gram per milliliter. It doesn't have to be exactly. But you record your initial volume, which mine is 25.5 milliliters. And then what you have to do is you have to take the little block of lead and drop it in and record your final volume, which mine is 31.9 milliliters. And then we have to take the difference. Oh my goodness, I'm so sorry. I just realized now my mic was muted. Okay. Okay. I'm so sorry. I'm going to start this page over. That is a noob mistake. So with question 3, You launch the simulator, and there's like this little square that's like floating in the water right at the beginning. You take it out, and you can click, do you want it to be iron, wood, lead? Click on the lead one, and take it out of the little beaker thing, and set the fluid density to 1 gram per mil, just has to be roughly. And then what you want to do is you want to write down the volume of the solution when the lead is not in there. So for me, it's 25.5 milliliters. For V2, you want to take that little chunk of lead and toss it back in. And for me, the final volume is 31.9 milliliters. And to find the volume of lead, you have to subtract your initial from your final, right? It's final minus initial. So, so 31.9 minus 25.5 is 6.4 milliliters, and sig figs wise, we have to have our last significant digit in the first decimal place, and we do. And so this would be our answer. Yeah, so in Canvas, whenever you're asked for a numerical answer, it'll tell you what units to calculate it in, like what's the volume in milliliters, but you just enter the number, no letters when you're doing numerical answers. So Mariah, something to keep in mind is your volume is always V2 minus V1, and V2 is final minus V1, which is initial. This will always result in a positive number, in a positive value for this experiment, because our initial volume is always lower than our final volume. So with this one, your value should always be positive. If you come up with a negative, it probably means that you have flip-flopped them, that you actually accidentally subtracted your final from your initial, but you should always subtract your initial from your final. Okay, let's see, Lizette. Question. On finding the nearest noble gas, when naming nomenclature. Okay. Yes, Lizette, that is a great question. And aluminum, to be totally frank, is the trickiest one that you'll have to deal with. Buffering. So when you locate aluminum on the periodic table, it's super tempting when you're trying to locate the nearest noble gas to want to maybe pick argon, because you're like, look, it's right there. But as you already pointed out, the correct noble gas to go to is neon. Neon is actually closer to aluminum, and here's why. If you look at neon, neon has 10 electrons. Whoops, I don't know why I'm writing a... And when you look at argon, argon has 18. So if you look at this, between aluminum and argon, this is a 5 electron gap. So aluminum would have to gain 5 electrons to have the same electron configuration as argon. Whereas if you compare neon to aluminum, this is a 3 electron gap. And that's why aluminum is closer to neon. So the thing that you're looking for when I talk about the nearest noble gas, you're talking about which noble gas is it closest to electron count wise. So you look at the electron counts, and the one that it's closer to electron wise with the smaller electron gap, that's the one that you're going off of. That is a great question, Lizette. All right, Abigail, let me check. Ah, Okay. So this one, so with problem, so we've seen, Samantha, earlier I was talking about how to determine the density of a solid object, one in which we could directly measure the mass, but then had to measure the liquid by displacement by taking a difference. For questions 12 and 13, oops, let me open a new slide. We're kind of doing the flip side of the coin. We're determining the density of a liquid. So this is the density of a liquid. All right, and density, as we know, is mass over volume. And here, we can measure the volume directly. We use a graduated cylinder for this. All right, but for the mass, this is where we have to get fancy when we're dealing with a liquid. We have to measure the mass by difference. So how you measure the mass of a liquid is like so. First, you have your scale. So this is my janky little mass scale. And what you do is you put your graduated cylinder on there, empty, and that's clutch. And you record your mass. I'm just gonna make up a number, 32.061 grams. This is our mass one. Then oh, why not? It's gonna be a little sloppy, but what can you do? Then what you do is let me just clean this up a little bit. Oops. So then what you do is you add your liquid to the graduated cylinder. So we're filling it up. And you record your new mass, which is going to be higher, right? Because this is the mass of the cylinder plus the liquid. I'm going to say this is 56.912 grams. And this is your second mass. Now, the mass of your liquid is equal to M2 minus M1, where M2 is the liquid plus the liquid plus the graduated cylinder, and the M1 is just the empty cylinder. let's see. super distraught.
He's not distraught, but only because he thinks you're gonna come get him, I guess.
I mean, I can't pull away right now. Like, I literally cannot. There's like shit with the simulator that's not going right.
Josh is teaching me. Alright, I don't know, he might freak out, but
Yeah.
it's
Sorry, babe. If a point slows, I'll see. But Okay, so I just finished doing some troubleshooting in the lab simulator. So I'm ready to do a walkthrough. So give me 1 second here. Okay, hang on. Okay. All right, so I'm gonna actually. Okay, so here's starting from complete scratch. Here is how to do the how to kind of use all the stuff. So we're gonna need a couple things. So from tools, you want to select scale. From glassware, you're going to select the 50 milliliter graduated cylinder, as well as the weigh boat. All right. From solutions, you're gonna select the big old thing of distilled water, as well as your metal of choice. My metal of choice is Mastodon, but that's just me. All right, now, one of the problems that we were having, so first off, you want to record your weigh boat mass. To do so, you put the weigh boat on the scale, write that mass down. Now, to add the metal, you want to drag the metal to the weigh boat and go to precise. So you've got precise, sig fig, realistic. You want to do precise. Oops, don't hit 101, hit 10 and click pour. Underneath there, it'll tell you 10 grams transferred. So now you can record this as your wayboat plus your mass. We X that out. That mass is still on there, even though it doesn't change the graphic. Now we want to add some water. So drag the water bottle over to the graduated cylinder. Go precise, hit 20 milliliters. Actually go sig fig, hit 20 milliliters. Then enter to pour. It'll tell you how much it's added. So this is 23.26. You would record that as your volume 1. All right? Exit out. Now, this is the final and tricky part. We need to pour our metal into the graduated cylinder. To do this, this is the only way I could figure to get it figure out how to get it to work. Go to realistic and click hold to pour and hold it till it's all gone and then let go. All right, it's saying the vessel does not have enough volume to completely transfer. That's weird. It literally didn't do this for me 1 second ago. All right. We are going to start from scratch. I'm going to get a new wayboat. And a new cylinder. So we got our wayboat, we have our mass there. I'm gonna go sig figs, enter 10, it'll tell me how much exactly. Next I'm gonna do my water. Let's go with more like 15. Invalid amount. Let's do 20. Okay, I had good luck with 20. It tells me that I added 19.40. Okay, and now this is the clutch part. Because to add your mass to your graduated cylinder, you got to go realistic, to the realistic mode, and you hold to pour till your entire mass is in there. Oh, and it says it doesn't have enough volume. Okay, then what we're going to do is we're going to try doing less mass and see if we can get better results. All right, let's try 5 grams and see how that works. We're going to try 5 grams there. And this, we record 6.67. That's important. Now let's go with a volume of 20. All right, this, and then we'd record 11.64. And now with the weighboat, we go to realistic, hold to pour until all 6 grams are added. It says source vessel does not have enough volume. All right. It says only 0.6 grams were transferred, so let's go smaller. If it doesn't have enough volume, it means that we have too much water or too much metal. So logic demands that we use less. We're going to go 2 grams. Wow. 0.3 was transferred. That doesn't seem like it's going to work. Let's just get a new weighboat. And instead of sig fig mode, let's go precise mode. Let's go 2 grams. 2 grams transferred. All right, so we're going 2 grams, 15 mils. This is metal 1. And we're going to realistic because we're going to hold to pour, and we're going to pour the whole thing. Source vessel does not have enough volume. Only 0.19 grams are transferred. All right, we're going to go smaller. If it says we don't have enough volume, that means that we're using too much, and we got to go even smaller. I'm going to go precise. I'm going to go 0.5. Let's do half a gram. Half a gram transferred. Now we're going to add water to our Erlenmeyer. I'm going to go 10 milliliters. 10 milliliters are transferred. Going to take my half a gram. Go to realistic. Hold to pour. Source does not have enough volume, only 0.5 grams transferred. All right. This may seem Sisyphusian, but we have to go smaller. I'm going to go precise. I'm going to add 0.1 grams. All right, so we're going to add, okay, so we added 0.1 grams. I'm going to go with 15. This is just silly. So, you know what the funny thing is? Literally before I put this simulator on the YouTube thing, I was doing it kind of in the shadows, and it works. So I wonder if our problem's metal 1. What if we tried it with metal 2? Let's go 50 milliliters. Let's grab a whey boat. Let's give this a try. Let's add a gram. Let's add 20 milliliters. All right. And now let's pour our 1 gram. Let's go to realistic. Hold to pour. Oh, looks like there's nothing. Hang on. All right. We're going to add 1 gram. All right, this is 1 gram was transferred. We're going to go to realistic and hold to pour. Source vessel does not have enough volume. You know what? Let's go with what Kevin's doing. Let's cut out the middleman. Graduated cylinder. Actually, let's add our volume first. Because maybe, you know what, Kevin? Maybe it is the whey boat that is... Okay, Kaylee, it worked for you without using the whey boat. Maybe that is jamming up our whole deal. Let's give it a try. Pop this thing on there. Boom. There we go. Okay. So here's the take-home message. That worked on the first shot. For questions 9, 10, and 11. Don't use the whey boat. Place the graduated cylinder directly on the scale. Dude, for real. Yes, totally. Totally right. The weight of the cylinder instead of the whey boat. Yeah, so the way that you're going to find the mass of the metal is you record what I'm going to call mass 1, which is which is the mass of the cylinder plus the water. And then you record mass 2, which is the mass of the cylinder with the water, with the metal. And the mass of your metal is equal to M2 minus M1. Ah, okay, so by find the tab, do you mean you can't find where metal 1 is? Okay, so it looks like a lot of people are struggling with this. So here, give me one sec. Okay. So here, let's start from a completely blank slate. Okay, so here's the deal. So we need to, so you want to, whoops, sorry about that. There we go. So you want to go to Stockroom, click on Tools, click on your scale to add the scale to your workbench. Next, you want to go to Glassware and select the graduated cylinder. And nope, actually, never mind. We're not doing a wave boat. We're just doing the graduated cylinder. Finally, go to Solutions, select the distilled water and metal one. Okay, so here, give me 1 second. Let me just give myself a little slice of screen real estate. So you're I'm gonna cover my face temporarily. Here. There we go. There we go. Okay. All right. So let's zero this out. Grab a new tab. Sorry, it's a little janky, but that's what we got to work with. All right. So we've got all of our stuff that we need. Now, here's what we need to record. Because we're trying to find the density of our metal. So we need to find the density. So we need the mass of our metal. And we need the volume of our metal. All right, let's start with the mass of our metal. So there's a couple things we got to do. I'm actually not going to start with the mass. Well, I'm going to do it all at once. I'll show you. Step number 1. Take the Erlenmeyer flask, and let's go precise, add 20 mils, pour. So we've just added 20 mils. So our volume, our initial volume, is 20.00 milliliters. Next, I'm going to take, so you'll notice, come on. Okay. Whoa, okay, it's freaking out on me a little bit. There we go. I had to remove my scale, but I can get a new one. Now I'm going to take my graduated cylinder, put it on my scale. And I'm going to record this mass. My M1 is 93.7439. Grams. This is the mass of my water and my graduated cylinder. Now, I'm going to take my metal, drag it over to my graduated cylinder, and let's add, let's do precise 5 grams. Enter. Actually, I take that back. Oh, well, now I messed everything up. We need to add more than 5 grams, sorry. Gonna remove that. Oh, this is gonna mess up all my numbers. Okay, sorry. We're just gonna have to start from scratch. Graduated cylinder, adding 20 milliliters, that'll be the same. But now we have to take a new mass one. All right, now my mass is 92. .7208 grams. Next, let's add our metal one to our graduated cylinder, but let's do 10 grams this time. All right. You can see that now my M2 is 102.7208. It's because I've added 10 grams of metal. And my volume 2, this is the important part that you got to record. My volume 2 looks like it's raised from 20 milliliters to 20.1. So my final volume here is 20.10 milliliters. This is the data that I've recorded from the lab simulation. All right, now I'm going to blank out the simulation so that I can have more room on my canvas to do the calculation. To calculate your density, your numerator, mass of the metal, is going to be M1, sorry, it's going to be M2 minus M1. The volume is going to be V2 minus V1. All right? So V2 is, oh wait, hang on one second. I wrote down the wrong volume, sorry, for V2. It's not 20.1 milliliters, it was 21.00. So 21.00 minus V1 gives us a volume of 1.00 milliliters. Oops. That's my denominator. And then my numerator is M1 minus, or M2 minus M1. Comes out to 10.0000 grams. So this comes out to be, oops, .0 grams per milliliter. All right, here, let me see the comments. Okay, so here's where V2 comes from here. Let me grab the studio and bring it back. All right, so you'll notice that oh, it doesn't show my cursor. So this is the way the screen looks immediately after I added the metal. And you can see that when you add the metal, it zooms in on the graduated cylinder. Sorry, I keep circling it with my mouse, but it doesn't translate in OBS. So you can see where the graduated cylinder is sitting on the scale. When you add the metal to it, the volume, it displays the zoom up of the volume right hovering over the scale. And it increased, before I added the metal, it was just kissing that 20 milliliter mark. But then when I added the metal, 10 grams of the metal, it increased up to 21. Okay, here, let me pop this. Yeah, I was just gonna say, Giovanni and Kaylee, it looks like you guys have the, if not the exact same question, very similar questions. So, this simulation is gonna look a lot like the last one we did. There's one key difference. So, you know, and which, by the way, for questions, which one is it, 12 and 13, you can't do this one in the simulation you used for 9, 10, 11. You've got to click the little link to open a new one. It's going to look exactly the same as it does here, which you'll see. So let's grab a volumetric, nope, not a volumetric flask, graduated cylinder. Let's get the big one. Okay, and then you'll notice for solutions, there's no water, there's no metals, and that's because you're finding the density of a liquid here. So again, density is equal to mass over volume. And the cool thing is, for the liquid, the volume is the easy thing to measure. So let's go ahead and grab solution compound A. Actually, we're gonna need our volume, M1 and M2. We get M1 by taking our graduated cylinder and dropping it on the scale. Let's see, that's 71.6557 grams. Oh, sorry, that's cut off just a little bit. M2. Okay, so that's so your M1 is just the mass of the cylinder by itself. Next, you take the cylinder, drag it onto the Erlenmeyer, and let's add 20 mils. So we've added a volume of exactly 20.00 milliliters. And now we have, you can see the mass on the scale, this is our M2, is a 96, let's see, what's that? 0.855. 7 grams. All right, and now we have everything we need because, let me close that there. So our mass is the mass of the cylinder with the water minus the mass of the empty cylinder over our volume. So 96.8557 minus 71.657 comes out to be 25 something. Let's see. Um, 96.8557 minus 71.657. Yeah, it comes out to be 25.2. But notice both of these numbers have their last significant digit in the 4th decimal place. So our answer must also have its last significant digit in the 4th decimal place. So this is our numerator, 25.2000 grams over our volume, which is 20.00 milliliters. So my calculator is telling me that my density is 1.26. However, I know that I need 4 sig figs in my answer. So I'm going to add a 0. And this is in grams per milliliter. So doing the one with the liquid is actually less complicated than the the solid because you don't have to take the difference of densities, or sorry, the difference in volumes. There we go. Sorry, it's been a long day.